One of the biggest issues people have with hypothesis testing is the distinction between one-tailed and two-tailed tests. In the reading that we've done so far, reading 10, the whole concept is around two-tailed tests, and that's what I'll start with, and I'll explain this concept through a simple example. You believe that the average return on all Asian stocks was not 0%, and so what you do is, so what's your population? Your population is the return on all Asian stocks, right? So you have a belief that the return was not 0%. The average return was not 0%. In hypothesis testing, what you do is you draw a sample and then you test using that sample whether your belief or your hypothesis is correct. That's the principle. So from the population, you draw a sample. The sample mean is 1, and let's say the sample size is 36. The population standard deviation is 4, and you want to use a 5% significance level. So what is your belief? Your belief is that the return is not 0%. Now, how do you test this? The curriculum gives a 7-step process, and strictly speaking, that's the long formal process for doing hypothesis testing. But most questions that you will get on the exam are based on a very simple 4-step process. What are those 4 steps? Step 1 is defining the hypothesis. Now, when you define the hypothesis for a two-tailed test, the null hypothesis has to have the equal to sign. And the null hypothesis is the one that you would like to reject. So if your belief is that the return is not equal to 0%, you set up the null such that the mu is equal to 4%. And then your alternate is that mu is not equal to 0. The alternate is typically what you are after. All right. So then, once you set up your hypothesis, second step is the test statistic. Now this is the formula for the test statistic. It's x bar. What's x bar? That is the sample mean. What's the sample mean? It is 1. Minus mu naught. Mu naught is the hypothesized value, which is 0. In our example, it could be something else in another example, but here your hypothesis is, or your belief is, the return is not 0. So mu naught is the hypothesized value. Divided by the standard error, which you studied before. What's the standard error? It's S over root n or sigma over root n, depending on what you have. So in our example, what is the test stat? Do we know x bar? X bar is 1, minus mu naught is 0, divided by what's the standard error? It is 4 divided by root n, which is 6. So 1 divided by 4 over 6, so that is 1.5. So knowing this formula for the test stat is essential. Okay, so you come up with the test statistic equal to 1.5. Then step 3 is the critical value. The critical value is based on the 95% confidence. If you are looking at your Z table and you are using 95% confidence, that means you have 95% in the middle. How much do you have in the tails? 0.025. So the critical value is plus or minus 1.96. Now, what you do next is you make a decision based on comparing the test stat with the critical value. If the test statistic is within this range, so if your test statistic is 1.5, which is inside this range, or less than 1.96, then you do not reject the null hypothesis. So in this case, what do? Do you reject the null? You do not reject the null. Now in business terms or intuitively, what are we saying? We are saying that with a small sample of, with a sample size of 36 and a sample mean of 1, that sample mean is not large enough to reject the hypothesis, the null hypothesis that the mean is 0. What if you had drawn a sample and the sample mean was 10, very high? then what would that do to the test statistic? Then the test statistic would be much higher. And then would you have been able to reject the null? Then you would have been, because then it would have been larger than 1.96. So again, just as to hammer this in, what's step 1? Define the null hypothesis. Step 2 is come up with the test stat. And then step 3 is come up with the critical values. If the test stat is greater than the critical value, you reject the null. If test stat is less than critical value, then you do not reject the null. Alright? Okay, next point. Now we go to a one-tailed test. So notice with a one-tailed test, as the name implies, you just deal with one tail. Now, you believe that the average return on all stocks was greater than 2%. The sample mean is 6%, n is 36, and you are given the standard error is 1.5, and use the 5% significance. Now, whenever you see either greater than or less than, if your belief is that the return is greater than something or less than something, then you are dealing with a one-tailed test. When your belief is that something is not equal to, then you are dealing with a two-tailed test. So notice here in our hypothesis, if you believe that the return is greater than 2%, that's the alternate, and then the other one is the null. The equal to sign always has to be in the null. So mu is less than equal to 2, so that's the null. So again, step 1 is coming up with the hypothesis. Step 2 is the test stat. Okay, so what's the test statistic? It is the same formula, which is x bar minus the hypothesized value divided by the standard error. X bar is 6. What is mu? Mu naught, the hypothesized value. Now it is 2. In the previous example it was 0, but now it is 2. Divided by 1.5, that's the standard error. So you have 2.67. This is the test stat. What about the critical value? Now this is important. You are still working with a 5% significance, but now this is only one tail. So all 5% now is in that one tail. Since all 5% is in one tail, the critical value then is 1.95. So if in the tail we have 1.65. So if in the tail we have 5% and this is 95%, when you look up the Z table, the probability is 0.95. With probability of 0.95, you will come up with a Z value of 1.65. A lot of people get confused by this, so I'll just maybe draw a two-tailed here in parallel just to illustrate the point. And you do this at least once. So if you have total 0.95, your cumulative probability, you look up your Z table and you will come up with a value of 1.95. Notice this 95% also includes the whole left tail. If we were doing a two-tailed test, then what happens? Then with 95%, it's 95% over here, which means there's 0.25 here and 0.25 here. So this 0.25 is less than 0.025, and therefore this number is larger. The Z value is 1.96. So when you are doing a two-tailed test and you have 95%, then the Z value is 1.96. If you are doing a one-tailed test and the Z value is 0.95, the probability is 0.95, then the Z value is 1.65.
If you found this lecture helpful, then I'll be very grateful if you can do 3 things for me. Number 1, like this video. Number 2, like my Facebook page. And number 3, visit analystforum.com, and there add my logo to your studying with profile. You can see this slide for help on how to do that. Thank you very much and good luck with your studies.